Have you ever wondered why hurricanes spin one way in the northern parts of the world and the opposite way in the southern parts, or why ocean currents follow such vast circular paths? It all comes down to an invisible force that shapes global movements. The Coriolis effect fundamentally deflects moving objects, like air masses and ocean currents, to the left in the Southern Hemisphere. This is a consistent and predictable pattern that helps us understand everything from weather systems to long-distance travel for ships and aircraft. This apparent deflection isn't a true force in the traditional sense, but rather a consequence of Earth's rotation beneath objects moving freely across its surface. Imagine standing on a spinning merry-go-round and trying to throw a ball straight to a friend across from you. While you aim straight, the merry-go-round rotates during the ball's flight, making it seem to curve relative to your spinning platform. Similarly, Earth's rotation means that different latitudes spin at different speeds. Points closer to the equator move much faster eastward than points closer to the poles. In the Southern Hemisphere, as an object moves away from the equator toward the pole, it carries its initial faster eastward momentum into regions that are rotating slower, causing it to appear to deflect left. Conversely, if it moves toward the equator, it moves into regions rotating faster, again causing a leftward deflection relative to the ground beneath it, as seen from a non-rotating perspective above the pole. This effect dramatically influences large-scale atmospheric and oceanic circulation patterns. For instance, it dictates the rotation of weather systems such as cyclones and anticyclones, which spin clockwise in the Southern Hemisphere, a direct result of this leftward deflection. It also shapes major ocean currents like the west wind drift, steering them in predictable directions and contributing to the formation of vast ocean gyres that transport heat around the globe. A fascinating insight into this phenomenon is its scale dependence. The Coriolis effect is only noticeable for large systems moving over significant distances and time, such as global winds and ocean currents. It is negligible for smaller, shorter duration events like the water draining from a bathtub, contrary to popular myths. This makes it a macroscopic driver, not a microscopic one, explaining why it's so critical to climatology and oceanography. Understanding the Coriolis effect and its leftward deflection in the Southern Hemisphere is key to grasping the fundamental forces that sculpt our planet's climate and ecosystems. It unlocks insights into the predictability of global weather, the distribution of ocean temperatures, and ultimately, the interconnectedness of our entire world's natural systems, providing a clearer picture of how our dynamic Earth truly works.